So our webinar today is on RESTful architecture, on the architectural underpinnings of RESTful services and how to deploy them in the wild. My name is David Chung. I've been a WebAge instructor for many years. And in addition to working as an instructor and trainer, I also work as a practitioner, as a developer and architect in technology, primarily in the Java space. But a lot of the work I do is with RESTful architecture, RESTful services, and RESTful clients, either mobile clients or clients that tend to be single-page applications. And AngularJS, or excuse me, Angular, the new Angular, is the technology with which I work the most on the client side. So that's a little bit about me by way of background. We'll go ahead and jump right in and start looking at RESTful architecture. In this webinar, we're going to look at these topics. We're going to start with a little bit of history. Where does REST come from and why REST? We'll look at what REST is. We'll look at REST versus SOAP. Let me see a show of hands. How many of you have built SOAP-based web services? Yeah, I've seen a whole bunch of hands pop up. I've done a lot of work in SOAP-based web services. I used to work for BEA Systems and then Oracle after Oracle bought BEA Systems, and did a lot of work in the service-oriented architecture space. And at the time, the most commonly used web service standards were SOAP, or was SOAP. And we'll talk about REST versus SOAP. We'll talk about the service and interface constraints that defined REST architecturally. We'll talk about RESTful APIs and API descriptions. We'll talk about some challenges with REST and some best practices. So I think that's plenty of content for our webinar. So let's get started. By way of history, way back in the 90s, as people started to get internet connectivity, dial-up back then and so on, there were a number of mechanisms that came out in the industry to provide for distributed communications. It was primarily distributed object communications, and the most common were from Microsoft DCOM, Corba, and XML RPC. But the idea was that we wanted to have a way to do distributed communications, and you had these frameworks. As I said, mid-late 90s was about the time frame. Moving forward, we started to see communication standardized around some XML-related standards, and you had SOAP and WSDL. SOAP and WSDL came about to allow for connectivity both within the enterprise and outside enterprise boundaries. Along with SOAP-based web services and WSDL, there were a number of enterprise standards or extensions like WS Security, WS Reliable Messaging that came along with this framework of SOAP and WSDL. And you had, in the mid-2000s, you had an explosion of web services, but they were all SOAP and WSDL-based web services. But later on, we really started to see and are in the middle of a different sort of service, services built using the existing architectural patterns of the World Wide Web, and that's REST or RESTful services. It is important to recognize that RESTful services are built on top of these web patterns and web standards. You can't really talk about the history of RESTful services without bringing up Roy Fielding. The idea for RESTful services first came about in Roy Fielding's doctoral thesis. Fielding is a personage, if you will, a somebody in the industry. He was co-founder of the Apache Foundation. He was a key player in the creation of the Apache web server, as well as a significant contributor to the HTTP URL and and I should say MIME type specifications. So it shouldn't be a surprise, given Fielding's background, that when Fielding addressed the problem of how you define services, connected services in an internet environment, that he went back to what he knows, where he's an expert, and that is the web. So Fielding's thesis proposes using these web patterns and web standards along with it in building services. Now, you may hear me say, and you'll see on the materials, sometimes I will say REST and sometimes I will say RESTful. The reason I kind of bounce back and forth is because unlike SOAP, remember SOAP is a standard, used to be called Single Object Access Protocol, but today W3C, who owns the standard, says it's just a proper name. Same with WSDL. WSDL is another standard, Web Service Description Language, but now WSDL is a proper name, no longer an acronym, according to W3C. SOAP and WSDL were standards. And there are a number of standards that have developed around SOAP and WSDL. REST is different. REST is not a standard, it's a way of life. So REST is not a standard or a collection of standards. It's really a collection of architectural patterns. That's why I will most often refer to services as being RESTful instead of REST. Because REST is sort of an idea, a way of life, not a thing. So I describe services as sort of following this RESTful path, if you will. The most common implementation of RESTful services is built on the web using web standards like HTTP, URL, MIME, and so on. You could follow the ideas of REST, these architectural principles, and not use HTTP at all. The reality is everybody does. So when I say RESTful services or possibly REST services, I am talking about REST over HTTP, which is the normal implementation when anybody works with REST or talks about REST. So in a nutshell, what characterizes RESTful services? Well, RESTful services start with URIs. URIs represent some resource, and operations on that resource are represented by the various HTTP methods. And the HTTP methods that are used in RESTful services are primarily get, post, put, delete, and patch. So you have a URI for some resource, and when you say get, that means you want it, it's the equivalent of a query. You want to read that resource. So get it reads a resource. You want to create a resource, you would call post to some URI. You want to update, you would call put. You want to delete it, you would say delete. That is, you would use the HTTP delete method. Now, you may look at this and say, well, Dave, that sounds a lot like the sorts of CRUD operations, create, read, update, and delete, that you would do in a database. And I'd agree with you. However, Fielding will tell you that there's nothing in his thesis that talks about CRUD operations. And he takes a little bit of umbrage at that. But the fact is, most people view REST that way. I see a hand raised. I'm assuming there's a question associated with it. Let me see. Okay, there we go. Does REST work only with the HTTP protocol? Yeah, excellent question. I'll give you two answers to that. The theoretical answer is you could follow the principles of REST in theory with a protocol other than HTTP. That's the theoretical ivory tower answer. The real answer is RESTful services are tied to HTTP in real implementation. So I haven't seen a RESTful application built over anything but HTTP. That doesn't mean it couldn't be done. I'm just saying that when people talk about REST today, they really are talking about HTTP. Though in theory, REST is a little bit like Agile. And what I mean by that is Agile is a set of principles and philosophies. It's implemented in a number of different ways, like Scrum is an implementation of Agile philosophy. Kanban is an implementation of Agile philosophy as well. So there are two possible implementations. Actually, there are more than that, but two that are widely in use of Agile philosophy. RESTful philosophy, there's only one, and that is tied to HTTP. So get, post, put, and delete. There's also patch to do partial resource updates. If you've worked with REST at all, you may be thinking, Dave, isn't there more to that? And I would say yes, put can be used to update a resource or under some conditions to create a resource. Put can be used to create a resource if you know the URI of the resource. So you want to create a resource. And what I mean by that is, let's say we have a system that manages flights for an airline. So we could say post, and we'll call the airline Dave Chung after me. So we could say post DC 123. So we want to create the flight DC 123. And let me bring up a text editor just to show you that. So if we want to post the flight DC 123, let's bring up my Atom window. Where are we? Oops, sorry about that. Let me lay back up. My text editor window isn't popping up. I'll bring up Word or something. I just want to be able to write a note that you can see. So I want to post a flight to a URL. And the URL is HTTP, Dave Chung Airlines, flight DC 123, called DC 1234. If I know, let's do this right. So I want to add a flight, and I want the flight to be called DC 1234. So I know the name of the flight or the number of the flight, sort of like if you insert a record into a database and you choose the primary key in advance. For this, you would use put. So if you know the URL that you want to post to, or that you want to insert. If I want to create a flight and let the system choose the URL, in REST, I would do this. And I'd spell flights right, probably. But you would specify the URL, but not the specific flight. And it's the responsibility of the service to return in the location header the URI of the newly inserted flight. So put if you know the URI, post if you don't. By the way, that means that put is idempotent in RESTful services, because if I say put flight DC1234, I'm always trying to add that specific flight to that URI. If I say post, I could end up posting information if I call it more than once. Since the system's assigning URIs, it could post DC1100, DC1001, DC1002 for multiple posts. So put is idempotent, and we use post to create a resource if we want the service to determine the URI. We use put to create a resource if we know the URI ourselves. Also, RESTful services take advantage of HTTP status codes. So for a GET request, we might get a 200 if we found the data. If the data is not found, let's say we've searched for a flight that doesn't exist, well, the web already has a standard way of returning a not found error, so we get back a 404. If we do a post or a put and create a flight, successful creation, there is an HTTP status code for that, 201. So we're building on top of these web standards as a way of invoking services and making requests and getting back responses. So here's an example. We're getting from a collection of cars, we're getting the car whose ID is 1234. The second example, we're getting the color of the car whose ID is 1234. And again, making use of the URL standard and this web framework, we're using now a query string. So we're doing a query. Once again, that's a GET. And we're saying cars make equals Ford. This would return a collection of all cars whose make is Ford. So all Fords in the collection. We can delete a car by specifying the HTTP delete method and the URI of the car, 1234, and put, patch, and post. For all of these, the data is sent in the request body. I see a question. Someone has asked, what happens on the back end when you issue a REST call? How does the web service actually translate into the operation on the back end? I'm not going to show you an example here because your mileage may vary depending on what the framework you're using. For example, you could be using Spring or Node.js, or you could be using a .NET framework. RESTful services are language and framework independent. But a big difference between REST and SOAP, a SOAP service has to parse the message body to figure out what operation to call. A RESTful service, the operation is determined by the HTTP method and the URI. So that's how it figures it out. What it actually looks like depends on the framework you're building in. I don't do much .NET, but in Spring, it's based on annotations. You map operations you map Java operations, those Spring methods, to URIs, URI patterns, and to HTTP operations. But Diana, that's going to vary depending on the framework you're using to develop your service. I see another question. What status would you return if you do a post, but add an attribute? Oh, but an attribute you provided has an invalid value. Ted, I don't remember off the top of my head what the standard status error is for invalid input. So one of the things that invariably comes up when we talk about RESTful services is REST versus SOAP. And it's a good question. Even though most or many modern services are built using REST, there is still room in the world for SOAP. They're not the same. It's not a complete or a perfect replacement one for the other. In fact, I was just working on a project, large project for a major US bank. And I was working primarily on the AngularJS client side, which uses REST. But as I got into some of the back-end services, there's still a fair amount of SOAP and some good reasons for it running within this enterprise. So REST versus SOAP. One big difference is SOAP is based on standards. SOAP and WSDL are standards, and there are a number of other standards related to it. REST is an architectural philosophy, though its implementations use a number of web standards. Huge difference. SOAP is transport independent. In other words, I can send a SOAP message over MSMQ, JMS. I can send it asynchronously. I can send it as an email attachment. I can store it in a file and use FTP to transport it. So SOAP is transport independent. I see someone's asked a question, what are some examples where to use SOAP and where not to use SOAP? Well, one might be if you're using a transport like JMS, MSMQ, FTP, or email attachments. Those are all supported in SOAP. REST relies on HTTP. In SOAP, the service has to parse the message body before it can even figure out what operation to call. In REST, the service uses the HTTP method to figure out what operation to call. In SOAP, there is a well-defined SOAP response that is an rather large XML envelope. In REST, we use HTTP status codes. And SOAP has responses and SOAP faults, which is their form of an error response. But REST builds on the HTTP status codes like 400, 500, 404, 201, etc. Another big issue about SOAP versus REST where you might use SOAP is that SOAP supports both synchronous and asynchronous communications. REST does not. Because as I said, our real-world REST implementations are built on HTTP. HTTP is very much a synchronous request-response protocol. So RESTful services are by nature synchronous. So if you need asynchronous behavior, if you have, for example, services that require store and forward, or reliable messaging, which the form is store and forward, where an intermediary will store a message until it can be consumed, that's a use case for SOAP, not for REST. Since REST uses HTTP, a RESTful service, a RESTful interchange requires that both client and service be up and running at the same time. In SOAP, I can put a SOAP message in a message queue. The client can go away, shut down, fail, whatever, and when the service recovers or starts up, it will receive the messages that have been stored for it. That's another use case for SOAP. SOAP uses XML for data, and most people think REST uses JSON for data. It does and it doesn't. REST is not tied to any particular data type. Now, for me, doing a lot of Angular programming, and Angular is a JavaScript library, the RESTful services that I use, I certainly prefer them to use JSON, because JSON is JavaScript's object serialization notation. So if I'm using a JavaScript client, it's really just a natural extension of that to use a JavaScript notation for my services. But RESTful services don't have to send back JavaScript. Many RESTful services in the real world send XML. They can send plain text. They can send images. It doesn't matter. Just like on the web, you can make a web request and get back an image or an audio file. It's all based on MIME types, which, interestingly, is one of the standards to which Fielding was a contributor. One of the challenges in SOAP, and you'll often hear people call SOAP a heavyweight standard, and I would agree, is that because SOAP uses XML and these very well-defined XML SOAP envelope, if you want to return a small result, let's say you're looking for the current temperature in Memphis, Tennessee. I'm going to Memphis on vacation next week, so I've been looking at the temperatures in Memphis. So you make a SOAP request to return the current temperature in Memphis, you get back 71 degrees. But that's wrapped in an XML envelope called a SOAP response that's got a lot of header information with it. And really, I just want 71 degrees, just a couple bytes of information. I get this massive payload back. In REST, I could represent that 71 in JSON as a simple JavaScript object that's only a few bytes long, or I could represent it as plain text and just send back a value, which is 2 characters, 7 and 1. So in REST, you have the possibility of smaller payloads. The one thing in SOAP's favor is that there are a number of enterprise extensions to add features to basic SOAP messaging. For example, SOAP supports a framework called WS Security. WS Security provides for message-based security. REST does not provide a standard way to do message-based security. REST and SOAP provide for transport-based or transport-level security, like TLS. What does that mean? It means that RESTful services can be sent over HTTPS, and they provide the security features of HTTPS, but only for messages in transit. If you want to secure your messages at REST through encryption, it's up to you to do it and to agree with your consumer how you're going to do it. SOAP provides a standard way of providing message level security called WS Security. And SOAP has these other extensions, WS Reliable Messaging for store and forward type frameworks, their message correlation IDs to build up multiple messages that support a number of asynchronous integration patterns. So SOAP has a lot, as much as I like RESTful services, I don't want to talk down SOAP too much. SOAP has some very, very useful features, and you may find that SOAP is compelling for those reasons. As I said, the large banks that I was just got finished working on a project for, they have room in their ecosystem for both SOAP and REST. Personally, I think they use too much SOAP, that they have some SOAP services that should probably transition to REST, but they have some SOAP services that I don't see transitioning to REST, that I wouldn't advise them to transition, because they do something that is very difficult in the REST world, particularly because they make use of asynchronous behavior and these enterprise extensions or WS star extensions for SOAP. And the reason that people call them WS star is because they all start with WS, these standards. WS Security, WS Reliable Messaging. There's dozens of them. So that's a little bit on REST versus SOAP. And as much as I am a fan of RESTful services, there is room in the world for SOAP-based services still. Now, from a theoretical level, we'll talk about the architectural style constraints and the interface constraints that surround REST and RESTful services. From a practical implementation standpoint, REST is built on top of HTTP. But from an architectural point of view, there are these style constraints. First off, REST is a client-server protocol. Very important, RESTful services are supposed to be stateless. That provides us a benefit. It makes it easy to scale. Stateless services scale very easily. You can simply bring on more service providers. You can route requests through those providers, round robin them, do a load-based balance of service requests. And RESTful services are cacheable. That's another very important part of RESTful services. For example, let's say I'm building an application for a retailer of some sort. Let's say it's a convenience store chain. And clients are using an Angular front end, and they want to find a list of all the convenience stores in their state. So let's say I have a client in my state. I live in Iowa. And for you, those of you on the coast, we're in the middle of the country, flyover country. So I go to the site and I want to look up all the convenience stores of this brand in Iowa. So I use my Angular application in my browser and I say find the convenience stores. I choose my state from a drop-down. I choose Iowa, and a RESTful request goes back to the server. It's a GET request because it's just reading data. And it's the URI would be /stores/Iowa, and that would return all the stores that they're located in Iowa. And then I navigate away from that page, or I open up another page. I come back and I want to find this list of stores in Iowa again. When I do that, there's a very good likelihood that my browser has that lookup cached. Just like it would if I'd gone back to a web page, it would have that web page cached. Now you may say, wait a minute, Dave, so your browser caches the web page, that's one thing, it's static, but should your browser cache this lookup? And the answer is, my browser doesn't know the difference between this service request and a request for a web page. The browser just sends an HTTP request to the URI specified and gets back a response. So the browser does cache it. Now, if you have very volatile information, you may want to configure what the browser caches or doesn't. But in many cases, the browser won't even make the request because it has the last request cached, and that has the potential to speed up and improve performance of the system. A RESTful architecture is a layered architecture. The requester of a service doesn't know if they're talking directly to the service provider or to some intermediary, to a load balancer, to some network appliance in the system. There's also a uniform interface between clients and servers. And it is possible, though this is optional, that RESTful services in Fielding's thesis, we also have the option for code on demand. We don't do much code on demand in the worlds I work in, but there was a time when we did code on demand outside of RESTful services. But in the early days of Java, we did Java applets where you get code on demand. And actually, in the world of JavaScript today, your browser is making a request to a server and getting back an application that may be written in Angular or a single page app in React. And that is a form of code on demand because it's downloading not just content to your browser, but code that's going to be run in your browser. So these are some of the architectural style constraints of REST. Also in REST, there are 4 interface constraints, and these are hugely important. The first one is that REST relies on the identification of resources. What do I mean by that? Well, if you go back and look at this example, this get example, this URI, carservice.com/cars. Well, this part of the URI /cars identifies a collection of cars. And then the further information, which we sometimes call extra path information in the URI, that 1, 2, 3, 4, identifies a specific car. So identification of resources. The second URI identifies a specific car, that is the car numbered 1, 2, 3, 4 in the collection, and it identifies a property of that resource, and that is its color. This one identifies all cars in the collection of resources where the make is Ford. I see someone has asked, can you explain what a layered system means? Really what we mean in a layered system is that the caller sees the system sort of as a black box. So the caller of this service, all they see is carservice.com, and they pass in this information. They don't necessarily know if they are calling into some load balancer, into an app server that's calling into some other server. You see the front end that's exposed to the system, even though the system is layered behind it. And it could be that there's a load balance layer. You don't need to know which service implements or which server implements the service. All you see is the layer provided by carservice.com. So identification of resources and mapping to HTTP, we use URI URLs for that. Next, manipulation of resources through representations. This is also a big deal. What we mean by that is, if you, back to the car example, when you do a get for a specific car 1, 2, 3, 4, the back-end service most likely gets that car from a database. Let's say it's from a Cassandra database or from a MySQL relational database. There's some database back there that contains the car. That's where the real car information lives. And you can't see that I'm gesticulating wildly with my hands here. I do that sometimes even though you can't see it. But it lives on the back end. What you get on the client side is a representation of the car. Most likely, you get a JSON or XML object that looks, and that JSON or XML object says car model equals Mustang, make equals Ford, year equals 1967, color equals red. That's your representation of the car stored in the database. By the way, there may be multiple representations available. For example, some clients may prefer a JSON representation, that is a JavaScript representation. Others may prefer an XML representation. In theory, I haven't actually done this, but you could build a web service that returned a serialized Java object as the representation. One thing I have done, and if you think about it, this is a car, the representation you get back might be a PDF sales sheet that shows a picture of the car and a description. All of those would be a representation of the resource, which is the car as stored in a database. Another part of this is self-descriptive messages. That is, the message contains the information necessary. And by that I mean the combination of message, all the HTTP stuff that makes up a message, which is HTTP method, HTTP headers, as well as URL and possibly content. If you have a post or put method where there is content, a get method, the content goes in the URL. So all the information necessary to figure out and decipher a message to make use of it is included with the message or request. The last of these interface constraints is the one that people struggle with the most. And if you talk to RESTful purists, it's the one that makes you RESTful or not. And that's Hypermedia as the engine of application state, or HADIOS. How many of you have seen this acronym before? Let's see a show of hands. Okay, I'm seeing hands raised, but not as fast as we did with some of the other questions we've asked. Hypermedia as the engine of application state. This is a significant part of the message that Fielding was trying to convey in his thesis. And let me explain what this is talking about. An example of this, I'll show you an example, and maybe that's the best explanation. An example of this would be Google. So let me show you what a HADIOS example from Google looks like. So I'm going to go to Google and let's search for something. Let's search for REST HADIOS. Okay. It's going to be a bunch of results, 146,000 results. Now, if you take a look down here, you see there's a page 2, page 3, page 4, page 5, page 6, page 7, page 8, page 9, page 10. Google is a stateless service. So when Google said there's 146,000 results, and I go back, let's say I want to look at page 6 in this list of results, I don't go back to the same Google server instance because it's already prefetched those 146,000 results. That would make it stateless or stateful and not scale, because every time you went to page 2 of a Google search, you'd have to go back to the same server. So when I go to page 6, let's look at what happens. Up here in this URL is all the information necessary. It says the query was for REST and HADIOS, and then there's extra information here, and that tells me that's the information necessary to reproduce page 6 of this search, or in this case, page 2, page 3. And any Google server I connect to, any Google search server I connect to, can take that URL and reproduce the previous, next, or a specific, like page 7 of my Google search. I could email, I could share this search with you. So let me go to page 5, and I'll copy it, and I just shared it in the chat. If you link on that, you'll get page 5 of my search. Now, your page 5 may be slightly different because these searches are updated, but the point is that Google uses Hypermedia as the engine of application state. So rather than loading up all 146,000 results into one server and forcing my request to go back to the same server, like you would if you were using stateless sessions in a web application. Google sends down, as part of the response, the hypermedia links to produce page 2, page 3, page 4, next page, previous page. So the application state is stored in the hypermedia links. That's a simple example of hypermedia as the engine of application state, but it allows us to build scalable, stateless applications. But as you're building RESTful services, I would take a look at that. And there are a number of good tutorials out there. You can do a Google search and find videos on hypermedia as the engine of application state. But it is a significant part of building RESTful services. As I said, some RESTful purists will say, if you don't use hypermedia as the engine of application state, you're not really doing REST at all. Data representation. RESTful services is representation agnostic, and we use MIME types to represent data. I see someone ask a question, where exactly are the results existing when we click on different pages? And if you're talking about the Google search examples, the answer is the results don't exist. What you're really doing is page 2 is a brand new search. So the hypertext link that Google sends back contains all the information necessary for Google to produce page X, Y, or Z of the search. That's the essence of Hatios. So RESTful services are representation agnostic. You don't have to use JSON, though that's most common. You don't have to use XML. That's next common. You can send any MIME type to represent the data going to the service and coming from the service. In fact, RESTful services can do content negotiation. So in my car service, I may say get cars/1234. That means I want, as a consumer, a representation of car 1234, and I can set my accepts header in my request and say, I will accept application JSON or application XML. The server then says, okay, the client will take JSON or XML, and the server says, I have JSON, so I'll send JSON. The client can also say, I will accept these types, but I prefer a specific type. And then the server will say, I don't have the type you prefer, but I see you accept this type that I do have, and that's called content negotiation, where the client specifies its content preference or preferences, possibly ordered, and the server looks at that, and based on the types of content the server can supply, the server chooses the right type of content to supply for the client. Because, as I said, clients may not want the same type of content, and this allows you to build a service that serves different kinds of content depending on the client needs. It's actually a pretty cool feature of RESTful services. Another big difference between REST and SOAP is that the SOAP standard was developed alongside, both from W3C, the WSDL standard. The WSDL standard gives you a formal way, in a human and machine readable manner, to fully define the interface of a SOAP-based web service. So it is a standard, and if you give me a WSDL file, I can write a client that calls your SOAP service. If your SOAP service uses some of these, what I call enterprise extensions, there are extensions to WSDL to support that. Unlike SOAP, REST does not have a single standard for describing APIs. In fact, it used to be really bad because you go and work at a project with RESTful APIs, and you'd ask about, I'd ask a developer, okay, where's the API defined? And they'd say, oh, here, it's on the wiki in plain text. It's in this spreadsheet. It's in this Word document. Or even worse, sometimes, I won't admit that I've actually had to do it, but I have. You would even invoke the service and look at the results to figure it out. There just wasn't a well-defined, common way to define services like there is in SOAP. There are some contenders, though. Early along, there was Waddle, and Waddle was not adopted by W3C as a standard, even though it was proposed. WSDL 2.0 can describe web services, RESTful services, though I have not had much experience other than playing with it to use it that way. The two standards that seem to be emerging as the winners in this are RAML and OpenAPI. And today, OpenAPI seems to be the one that's winning in this space. There are a number of tools. You'll see the word Swagger. Google search on Swagger and OpenAPI, and you'll see tools to support services that use OpenAPI. I see someone says, will you be sharing the slides with us? The answer is yes. I think you'll be getting an email from WebAge with a link to the slides, but they will be shared at webagesolutions.com. Someone asked, can we respond with different representations for a single URI? And the answer is yes. That's what makes this cool, because a client, as part of the request, will say either, here are the representations that I support, or here's the representation that I want. And they all ask at the same URI. And as long as the service can respond with to the client request, with the representation they want, the client will get the appropriate representation from the same URI. That's one of the cool things about this content negotiation. Someone asks, what's the difference in the concept of API and service? It sounds like the two terms are used interchangeably. They're used, I would say they're close to interchangeable. I tend to think of an application programming interface as including more than just a single service. I sort of think of that as a larger thing, but an API could be used, for example, OpenAPI, RAML, could be used to describe a single service. So I'm not sure that I have a good answer for that question, but that's how I view it. Some challenges in RESTful services, and we're running out of time here, so I will move forward. Someone's saying, how can someone request XML or JSON from a URI? And that is set the accept header, ACC EPT header in the request. I'm sorry, I don't have time to show an example, but the header is and in its accept header, I put that out in the chat, and you would set the content type like application/JSON. And I'm sorry, this should be if that's the type that you want. And how you do it on the server side, again, it's different depending on what framework you use to build your server. So some challenges: security. Now, I'm not saying RESTful services are insecure. I'm saying REST itself does not define security standards. So you can use any number of security standards. Most often we use SSL to provide for security in transit encryption, strong authentication of the server, optional two-way authentication. But there are others. You may want to use some sort of token-based framework if you need security of data at rest. And by at rest, I mean not at rest is in RESTful, but data that's not in transit, then you need to provide that for yourself. Another is there is no standard for API versioning. Of course, anytime you build an API, you want to build a stable API, but the fact is APIs change over time. So there are a couple of mechanisms for API versioning that involve the URLs. Another challenge, and this one actually comes into play, if you do very complex gets with very complex query strings, there is a URL size limit. The practical URL size limit, I believe, is 2K. That is the practical, should work everywhere. So if your query ends up being larger than 2K, you simply can't use a GET request because you can't send it over HTTP. So that makes it hard to follow REST religiously. Likewise, for security purposes, the bank I worked in used sort of REST-like or REST-ish operations because for security reasons, they couldn't put customer information in URLs. So that limited our use of GET requests. Yes, they were secured by HTTPS, but they had to be decrypted by load balancer, network appliances, and so on. So we used post requests that encrypted the content for many services. When following RESTful principles, we would have used GET. Also in REST, because it's tied to HTTP, you don't have asynchronous transport or alternative transport reliable messaging. Some best practices. In naming your URIs, only use nouns like cars. You can use sub-resources like cars/used. You can use query parameters to filter, sort large results. So you may choose to return only 10 results out of 1,000. Use MIME types in content negotiation. Consider HTTPS. Use HTTP status codes for responses. And when you have errors, return an error payload with meaningful information to your client application. As I said, we're running out of time here. I just want to point out that at WebAIDS, there are a number of classes we have on RESTful services. This is not an exhaustive list. You can take a look and search our catalog at webaidssolutions.com, search for REST or RESTful, and you'll see a whole bunch of RESTful services using different APIs, different tools, server side, client side, all of the above. I want to thank you for your questions, and you will be getting an email that will have a link to both the slide deck and this recorded presentation. So thank you very much, and I hope you've enjoyed our look into RESTful service architecture. Thank you, and I'm going to sign out of the session.